We have already looked at one version of the script in an old farming area of Jordan using site polygons. The script can also be used for automatic change detection with sites with point geometry rather than polygon geometry. We are going to look at another example, this time from Jufra in Libya, in an arid area which has undergone massive agricultural expansion made possible by modern irrigation techniques. First, we are going to look at the changes we have made to the script to make it work for our Jufra sites. Open the second version of the script. There is a link in the video description. Unlike the Madaba sites, which are polygons, the Jufra sites have point geometry. In the code editor, scroll down to line 127. You will notice that to make the script more effective, we can create a buffer zone around the points. At the moment, this is set to 100 meters, but we can change this if we wish to make the area around each site larger or smaller. Turn off all the layers except all sites. If you zoom in, you will notice that all the sites are circular and roughly the same size. In fact, they have a radius of 100 meters, as we set in the script. Scroll up to line 5. You will notice that for this script the dates are different. We are looking at the months. We are looking in spring 2020 and spring 2019. Precisely the months of February to April. Turn on the change layer. As new agricultural areas are a major type of disturbance in this part of Libya, the script is programmed to compare this change layer to our sites, instead of the change no agriculture layer, like in the Madaba example. Turn on the change including agriculture sites layer. Expand the two feature collections in the console window. You will notice that there are 76 sites in total, and out of these, change was detected in 13 of these sites with a radius of 100 meters. We are now going to follow exactly the same methodology as before to validate the Jufra results. Click on the Tasks window, and next to Detected Change Raster, click Run. For Drive folder, type ACD Jufra and click Run. Repeat this for the changed sites export shapefile. And wait for these tasks to complete. When the export tasks have completed, click on the question mark and select Open in Drive. Your ACD Jufra folder will open with your shapefile and your detected change raster. Again, click the arrow next to the folder and select Download. And then save it or move it into your ACD folder. And then, just as before, right click and go to 7-zip and extract here. An ACD Jufra folder will appear, and you should just check that you have your shapefile and your change raster. Switch to QGIS and add these files using the Open Data Source Manager. And if we right-click the raster and select Zoom to Layer, it will take us to the Jufra area of Libya. If you need to, make sure the sites sit on top. As before, we need to change the symbology of this raster. And make sure that we can see the satellite imagery through the sites. Now, as you can see, we can see the underlying satellite imagery, the change raster, and our sites with the imagery through them. As before, we open the attribute table and then dock it using the Dock Attribute Table button. And sort the sites alphabetically by clicking once on the primary NA field. Then we need to open these in Google Earth. To open the sites in Google Earth, we again go to File, Open, find our ACD Jufra folder, and add the shapefile. Click Yes, click OK, change Set Name field, this time to Primary NA, and then click OK, save, and yes. We turn them on if they're not on, and you can see they have appeared. To be able to see the satellite imagery through them, again we right click, go to Properties, click Style Color, and click Share Style. We change Filled and Outlined to Outlined, and we change the line color to something obvious, and we make it thicker so they're easier to see. And now we can see all of our sites through the satellite imagery. Then expand the sites we're working on, right click the folder and select Sort A to Z so that they appear in the same order as in QGIS. So in QGIS, click on site Iamina 1512 and then select Zoom to selected rows. Switch to Google Earth Pro and double click on site 1512. We now need to use the time slider to find the relevant imagery. This time, remember, from the spring of 2019. So if we just go back, you can see that in March of 2020 there was some flooding at the edge of the site. And if we compare this, this is the area of change that was detected in Google Earth Engine. So this is a genuine disturbance to the site that needs to be recorded. We will do one more site. So zoom in to site 1547. You can see here large areas of change detected right across the site. And if we go back through time, we can see that at some point during this period, this ancient irrigation channel was almost completely destroyed by the planting of an orchard. This is obviously an extremely important disturbance that we have picked up automatically thanks to Google Earth Engine. For this tutorial, we now want you to finish validating the results of the ACD script for Madaba and Jufra. Go through and identify the disturbances that have occurred to archaeological sites that have been detected in Google Earth Engine.